Today's panel discussion is on data, right? And this is a very interesting topic for various reasons. It's all about data and the things we do, the way we attract customers. And as technologists, the choices today are umpteen, and it could be about data stores, processing frameworks, trends, how people are using it differently, and so on. And towards that, we have a very experienced panel today. I'd like to invite them on stage. First, Dr. Pramod Varma. So, Dr. Pramod is an advisor for a few government projects, as well as sits on the advisory board of startup companies. And Pramod, the most famous phase of his is as the chief architect of the Aadhaar project. Just for numbers, so 1 in every 5 Indian has an Aadhaar number. So I'll tell you the significance of it in a little while. But prior to that, Pramod was also the chief technology officer of Sterling Commerce. So with a lot of experience on transactional systems, and he has, I have a complex reading out his educational qualifications, so I'll just skip that, okay? So next we have Joydeep Sen Sarma. So he heads up the engineering at Qbol, and Joydeep comes with a background at Facebook. He was responsible for bringing Hadoop systems into Facebook. He's also the creator or one of the creators of the Hive project. Thank you, Joydeep. Awesome job there. So you think these guys are great. I'll just get to that, okay? So, and he was responsible for technology selection of Facebook messages. Now, these two gentlemen here, one of them probably has more data about you, okay, which is Pramod, and Joydeep probably knows what you're telling your friends, right? So, so rather than say that it's a data privacy concern, I would say just see the way at which the kind of data-related system they have created that is touching us in everyday life, right? So it doesn't stop here. We also have the third gentleman, Anshum. Now, Anshum is a search guy, okay? So he works for LucidWorks. Those of you who use Lucene, today Sharad alluded to that as well. So probably the de facto standard for search. Now this is a deadly combination. So one who has biometric data, the other guy knows what you're saying, and the third can find out pretty much what you're saying, okay? So a lot of experience here on the search side. Anshum comes from a background at ClearTrip, Naukri.com, and also built out the large cloud search system at Amazon, right? So now works for Lucene. Very unassuming folks, all of them technologists. The fourth panelist is Ashok Banerjee. Ashok is VP Engineering at Flipkart and heads the data platform team. He comes with a lot of tech background or data background, as I would say. So his prior experience includes working for Twitter and Google. Okay, so the entire world's data is up here. And the fifth panelist is Utkarsh. Utkarsh is principal architect at Flipkart, and he is tasked with making life different for us to consume digital content in India. So he architected the digital platform of Flipkart, and so therefore brings another dimension to data. What were they, and how did you see data challenges, or how did you solve those data challenges using frameworks? Let me just qualify that a little bit. So as technologists today, we have too many choices, right? So on one side, you have the Hadoop ecosystem not starting just from analytics, even trying to serve real-time data. And the other extreme, you have Lucene-based systems being used for search, for reporting as well. So given the complete spread of choices, so what are the guidelines that you probably take when selecting a data store or a processing framework, right? That will really help us clarify this plethora of technologies and what we could be using. And those specific examples on the areas that you have been working on in recent times. You can take any particular order that you want.
Who's starting? You want to go? it's about whether the messaging, whether it is a sync processing or async processing. If it's async and you don't need instantaneous results, I find it much more useful to do much deeper analysis on the Hadoop infrastructure. If it is sync and I need quick, latency sensitive, that's where I lean towards more of the Lucene type of storage. Again, another good way is to look at whether it is CEP oriented, intrusion detection oriented. Those are sync. That's where I split it off. I also look for the sync systems, whether the metrics you're looking for are online aggregatable or not. Online aggregatability is about stream data flowing in and incrementing some counters, incrementing some variables. Let's give some examples of a couple of online aggregatable things. Mean, standard deviation, these are online aggregatable. The distinct clause in SQL is not as easily online aggregatable. You have to keep a track of everything that you've seen otherwise. So those are a few things I can come up with.
Joydeep?
Joydeep, you go ahead. And right in the house. I think this is a very big question. So if you ask me as a technologist what I have found interesting, there's a part of the world, data storage systems, technology landscape, where there's a lot of discussion about the CAP theorem and what kind of trade-offs need to be made, which class of systems is the big data kind of big table systems, dynamo systems, or spanner and all this stuff. I think as a hardcore technologist, I find that extremely intriguing, and I've sort of participated a little bit in that discussion. And so there's no universal answer, even in that one niche that I chose. It's sort of dependent on what your consistency criteria are, what your partition tolerance properties required are. Whether you planning to set up data centers that span wide geographies, and what that means to your architecture. And to some extent, going back to what Ashok just said, what kind of things can tolerate inconsistencies, or can you model your application in a way where it is loosely consistent, and still you can deliver the product experience that people were talking about earlier. So I find that very intriguing. On a more a person sort of running a business, or who's run sort of like a team within a company like Flipkart, similar sort of setting, I think one of the things that we obviously it's very hard for a large company to do, and especially as Flipkart evolves, is that sooner or later your operations guys, your DBAs, your sort of everybody's going to say, look, this is what we run. We run MySQL. This is the only thing that you're ever going to get from us, right? And so there is a loss in diversity that happens at a large technology companies, because we try to achieve economies of scale by standardizing platforms. And it is very clear that that is actually a downside. I mean, you're getting the economies of scale, but you're also getting you're losing competitive advantage, because the guy next door starting the next e-commerce company loves MongoDB, and it has certainly become good enough, and there's ecosystem around it, and guess what? He can probably make his schema changes way faster than you can make it in MySQL, right? So I think that's a sort of an interesting challenge for larger companies, to how to keep that environment alive, where people can actually start up different classes of systems, because there is no perfect system for all problems, right? I mean, in memory, unstructured data, document databases. So a couple of things that I can think of.
Yeah, I don't claim myself as a technologist. I think I've been always solving business problems. I come from building really large-scale retail supply chain systems. So the back-end systems you probably have, pick, pack, ship systems, warehouse systems, transactional systems, very different choices. So I think that's really, as Joydeep was saying, it's context-driven. So it depends on what kind of data, what kind of tolerance to, or the schema changes or anything that you require. But tolerance to failure, I want to talk about a little bit of that. I think I always worry about reliability of a data store. When I choose a data store, I want data store to be reasonably reliable. I actually am a believer that performance can be handled outside. So I think a lot of times we tend to confuse between performance and reliability, and it's very different choices. So for example, when I came to UID, architecting Aadhaar, I mean, you've been part of that, and you know that. So we ended up doing a combination of RDBMS and HBase, because there were two different reasons. I know when we said HBase, we use it for extremely large scale, persistent edge cache of sort. You know, this is when authentication hits us, 100 million authentications a day. And you want to be able to scale that to multi-data center very near the edge. But that's not my billion people's UID master of sort. That's not the permanent data set. I want that to be extremely reliable. When I give Aadhaar to a person, you should never say, oops, I messed up your data. Not acceptable. I think it's a combination. So it's never a single choice. And when we did Hive, thank you. So we were big users. When we did continuous improvement, that is one of the things we did. We have 1 lakh operators on the ground today in India, 1 lakh, 100,000 people enrolling using our software. How do we know the software is running well? How do you know how long they're taking? So we actually measured entire data. So everything that goes on the ground today in 100,000 stations, 100,000 people, 50,000 stations across the country, every time the user flips the screen or crashes the system or restarts the system or relogs in, we measure everything. And all that is, data, I don't care. If I lose 1 hour worth of data, it's not a big deal because it's about analytics, it's about intelligence over time. So we put that in Hive. So my choice of Hive there was because it was easy to do analytics on top of it. And you know what? The reliability of data was okay. I mean, I didn't really lose sleep over not having data. It's really confusing out there. A lot of data stores, but
this
choices.
This is actually a very interesting topic that you bring about relaxing consistency over, or rather correctness of data, right? So most of us come, and those of us who come from relational background, consistency and correctness was paramount importance. And now with web scale and social data and stuff, we seem to have taken a back step, saying it's okay to compromise consistency over scale. And I'm sure, again, going back to even the Flipkart experience, you can probably search for a product, and only when you probably get to the checkout stage, you find out whether it's in stock or not. Right now, is this a trend that's happening, or is this an acceptable trend to compromise, say, consistency or correctness in favor of scale?
No,
or is it only for analytics that you're talking about?
I have a very different take. I mean, again, I don't come from writing hard technology for it. So in fact, I built large-scale order management system. I am very sure in your order management system, you would never want to lose an order. If a customer orders and says, sorry, I can't find your order, bad answer. I think that's not acceptable. Go to your warehouse management system and ask, what's in an aisle? When you put away something in the warehouse, do you actually ensure that inventory is counted? How do you get inventory accuracy? Choices are different. So the data store, their choices are very different from a large-scale product search or promotion engine, for example, where people who search this also search this. It's okay. That's okay to get near good answer.
Yeah, so that actually leads me to the...
Very quick, Pramod. Am I still audible? Okay. So in the old world, RDBMS, 80s, there was no throwaway data. So I think partly the throwaway data has overwhelmed, the highly valued data. So that's why, partly why we are seeing this transition.
So is it fair to assume that there is still or what we store as, you say important data, there is still a value in strong consistency, and for throwaway data, consistency can be compromised. Is that acceptable?
I think there's a lot of throwaway data that's coming in because of the rate at which we're receiving data. And as you said earlier, we never had that much data, so there barely was any throwaway data. With the amount of data that we're collecting now, the richness of systems that we have, the number of systems that we have, with all those inputs coming in, we have so much of data we're on the verge of getting overwhelmed probably, and we're fine with letting go of a bit of it, because that in the longer run up or longer scheme of things, we barely lose out on anything there.
So Utkarsh, on digital side, right? So what are the kind of challenges that you see in terms of the media that's coming? They're starting from MP3 to probably even movies. So with respect to data stores, what are the choices that you make?
Sure. So in the digital side of things, the kind of content that you deal with is varied. You can vary in terms of size, from few kilobytes to even gigabytes of data, and even the kind of data processing that you need to do on the content, it being a media file, a document, or it being large video files. You need to do some pre-processing or maybe on-the-fly processing. So it really it becomes a huge monster to solve, that you have different kind of content and you have different kind of processing required on the content. So one solution fitting all is nowhere a solution. So you need to be savvy about the semantics of the data. I guess I'll just expand on Pramod's thought. The choice of a data store should be much more relying on the functional aspect of things than the non-functional. You can't just start off by saying that I need scale, I need performance, let's go with NoSQL stores. That's not the way to go about choosing a store. You need to just focus on the functional aspect first. Understand your data, characterize the data well enough, variability of the data, how is the data form changing over time, is there enough flux in the data form itself, is the schema changing over time, am I adding, deleting columns much more often, and if I'm querying the data, is my index subject to change a lot more. So in the digital side of things, one aspect was how do I store the content, the digital content optimally, so that it is accessible, it is processing ready, and it can be served in optimal times to the end user. And then to the catalog side of things, if I'm maintaining a huge catalog, there the challenges are much more functional in nature. I need to see that the index that or the key that I use to identify the data on day one, is that going to be stable for a longer duration? Maybe not. Just as a small example, take the case of a book. Ignore the case that every book may have an ISBN. First day assumption could be, okay, let's go by a title. Titles can be same across publishers. So then you modify index. You say, okay, title plus publisher. But is that good enough? You find out, okay, now titles are coming out with sub-editions. Title plus publisher plus edition. And then you can have multiple variants. Hardcover, paperback. So you just don't stop at the semantics on day one. So here we are not thinking about the choice of a data store just because it's scalable, it can support huge volumes. Here we are talking functional. We are talking about the semantics of any feature that data store can help me with. So for me, those are the ground rules. I'll go by the functional choices first, and non-functional SLA choices, I think any of those can be solved with a lot of heuristics and maybe a lot of tooling around it.
So going to almost on the trend side, right? So how do you see infrastructure changing your data store choices, right? Sometime back, SSDs were prohibitively expensive, but now that's changing. Now, I remember Joydeep talking about trying to leverage Flash extensively at Facebook and trying to do things with that. So how do you see this changing? I mean, do you see a move towards software-defined storage, or will we still be going back to monolithic hardware-driven storage devices, or is there a play for both these kind of systems, right? Your regular filer systems as well as commodity servers, low-end infrastructure, cheaper hardware, but better, higher IOPS. Does that change your technology choices? And there's always, we are all aware of the Moore's law and how that's making some of these, or rather affecting the choices that we make. So where do you see infrastructure heading, and how does that implement data stores or processing frameworks?
I think in my mind at least, SSDs are giving you lower latency, but we can get high throughput by sharding. And sharding gives us pretty dramatically higher throughput, and especially if we are doing larger buffers, if that's what our store allows us. Basically, the semantics allow us. So across these two, I think we are doing reasonably well in the choice. I would go with just sharded stores where I can. And if it's high IOPS needed, like for, say, a MySQL transactional system, I would then use SSDs. I think another place where my choices kick in, I was listening to all the responses and it helped me formulate my thoughts. It's not about the semantics. My infrastructure choice is about the access pattern. Is it primarily read? Is it primarily write? Create, update, delete? What is the pattern that we are doing? And there are different stores for those. It's not even just an RDBMS versus a MongoDB. Even within an RDBMS, if I chunk in a blob, it is going to be a lot quicker to write than to structure it into 10 columns. I structure it into 10 columns so that I can read it by those. Again, the consistency, I'm going back to a previous question, consistency versus scale. It's about aggregate data versus exact data about a pinpoint. The aggregate data of how many shoes have we sold, we can be off by 10 or 20. Did you buy a shoe? We cannot be off. So aggregate versus exact line item, those are the choices which I tend to make.
Sure. I mean, that relates back to...
Yeah, just one point. I think, again, the technology will continue to evolve very rapidly to make things cheaper, faster. That's taken for granted, right? It's happening. So the performance aspect, again, this is a difference between performance and functional need of the data, right? So the performance aspect can be solved by throwing some SSDs, in the mix, hot tables, make sure, they are on the the storage on the SSD and so on. And even the memory is cheap. These days, memories, you can put a lot of stuff into memory and make it faster from an application point of view. So I don't think you should mix that into the data store selection aspect of it. So fundamentally, data store selection, for me, is it reliable data store? Second thing is, do I need a structured versus semi-structured versus a completely unstructured kind of data store? So we have to choose between that, and if it's a very rapidly evolving data structure, like he was talking about, very different metadata, attributes are very different across media files and types of media. You can't force fit everything into a RDBMS-like table. So you choose something like MongoDB, for example, very flexible data structure. But SSD and other parts, it's performance mostly, and it'll continue to be cheaper.
Sure.
I'll just quickly add. So what's happening with SSDs is that life is not changing for people here, mostly. Mm-hmm. But there'll be a new class of applications that will leverage the capabilities. So previously, where you would not write an application because the lookup rate was so obscene that you had no hope of pulling it off, you would now write it. So a good example is a company called Nimble Storage, I believe. They are doing deduplication. Deduplication is a very index-intensive problem, and it requires tremendous lookup rate. And previously, companies like Data Domain did it in the past in a batch mode because they just couldn't do those lookups in real time. But these guys went ahead and said, well, now we have SSDs. We'll just run a indexing engine on top of SSD, and now we can do real-time online deduplication. And they've created a a few $100 million company by just doing that, right? So that's one thing. Another thing I think is sort of happening. I don't know how many people are aware of this. Is that we are probably, even Flipkart is probably buying these 1U, 2U boxes with a few sockets, CPUs, shoving them into racks and racks and racks, and that's our sort of data center. That's our computing sort of engine. You see, Facebook came out with the Open Compute Engine announcement around sort of custom chases and having CPUs as cards on a larger chases. You have companies like C-Micro who are putting like hundreds of ARM processors on a very, very tightly connected backend. So we, typical technology curve, we are going back to like thinking machines or those kind of architectures, where we have extremely dense and extremely superbly connected CPUs. And I think that's going to be very interesting over the coming years because it's going to give a choice to, frankly, it's a challenge for a company like us when we're building things in the cloud who don't have like control over the hardware, but to a company like Flipkart, do I buy one of these like, golden boxes with like, 1,000 CPUs and a fantastic interconnect, and that's my Hadoop in a box, right? Or do I, put up these older class of systems and, so that, I think that's going to be very interesting in my mind.
Sure. So I think we're really towards the end of the session, running short of time, but I want to just seek your views on a couple of trends and then maybe open out for questions. So one of the trends is delete is, as an action, is almost becoming a forbidden word, right? So for how long can this sustain is one, and what are your views on that? And the other thing would be like, we all talk about MapReduce, and well, there are companies trying to adopt MapReduce. MapReduce almost seems has attained a term of being monolithic. Okay, so and the trend seems to be more towards real-time analytics, right? And solutions that are coming in that space. So what are your views on either of these? One is delete as a forbidden word, and where do you see real-time analytics going?
Personally, I think again, it goes back to storage is very cheap. So store as much as you can. A lot of people, business guys, feel the data will come in handy later.
So how big is the largest data that you have holding?
For example, we haven't deleted anything in Aadhaar project so far.
So how big is it?
So we are about 5 petabytes now.
Okay.
Yeah, so it's pretty large, and some things we can't delete, like people's biometrics and so on. They are a highly encrypted blob binary structures. They are not going into any data store in that sense. I mean, it's a file data store. But but deletes, I think archival will happen. Deletes per se will happen over time. I don't think, because again, it goes back to his point, the rate of data, producing of data is just exponentially increasing, right? I don't know how far we can keep it. Aggregate data. I think that's what people keep it. People constantly do aggregation. You might keep it for 5 years, but beyond that, you start aggregating and just throw it away. I think you'll eventually delete. I don't know whether you can store forever.
Were you talking about delete to archive or delete from the operational store? Which one was your thought? Or
well, this is a trend. So depending on how you choose to interpret, but yeah, obviously, like Pramod said, you don't want to lose important information, but at the same time, this trend of saying, you see adverts saying you never have to delete an email or never have to delete a picture. So how far is that trend going to continue, or are they making these, these statements just knowing that you don't really care if you happen to lose them?
I'll talk a bit about what Flipkart has, at least. So in the supply chain systems, the databases are growing. They can't keep growing forever. Whatever hardware we put, if we are stressing it out at these order levels, what happens 2 years down the road? So we will have to archive. Today we have from time T to beginning of time for Flipkart in one database. We will have to archive. We will archive to more analytical stores. If something needs a restatement, that goes into the operational store. Beyond the analytical stores, after some point, our Hadoop analytics infrastructure, that will also be bogged down. We have too much of data. We have already been talking about archiving a level beyond that. So what we are seeing is not deletion, but tiered storage. Tiering from hot to gradations of less hot. We are not yet thinking tapes, but we are thinking all the way down to ZFS. What was the other one?
Sure. So Joydeep, in the cloud space, which is your specialty.
Nobody else wants to talk on that. Let me make a quick point. It's actually getting very hard to delete data because all the real stress systems are log structured systems, and it's getting almost impossible to actually, like, at Facebook, right? We had to delete data not because it was expensive, but because people say, when I delete my account, please go ahead and delete my data. And I can't tell you how hard it was for all the teams involved, photo storage, log storage, like, how are you going to go across all these like hundreds of boxes, find that one little 1 kilobyte chunk, and actually erase that? It's going to kill our boxes. The random IO, we don't have those random IO.
Yeah, that's a very interesting thought, and in fact, I'll state something. Really, this whole area around up-and-only stores, right, becoming the matter of choice these days, and it's a very interesting thought. Anything on real-time analytics before we open it out to the audience for questions?
I'll just add one little thing. We haven't started anything really on this front, but what I find is you have the batch analytics, and then you overlay real-time analytics on top of that. So your graph will have 99 points from your batch, 1 point which is a counter from your real-time system. And then you're studying often for trends like above the 20-day moving average for some variable. So that gives you the alerts and everything downstream.
So is it really a hybrid model that you're talking about?
It's a hybrid model.
Batch and real time, and is there a play for machine learning as building on top of this?
So what I think is ML is on the batch, machine learning on the batch. You come up with decision trees, you come up with rules you execute, and the rules are executed live on the final real-time points. So you learn and figure out the rules from the batch system and then apply dynamically on the real-time system.
Cool. So we have actually stepped in or overshot our time, so we'll permit a few questions before we break for tea. So we have one there. So you can address either individual panelists or the group as a whole.
Yeah. My name is Vivek. I have a question to the panel. So especially around data processing platforms and cloud services emerging of commodifying these data processing platforms for startups. What is your take on scenarios where you go ahead, use these platforms, and then over the period of time, let's say 3-4 years, when you want to create strategic innovation and you want to control these data processing platforms, you are still stuck with the common denominator for everybody because you're using an economies of scale service provider, and you don't have a control on the how do you optimize the data processing platform to your business so that you can compete with your the other peer sitting trying to overshoot you. So this control over your data processing platform versus giving away or using a third-party commodification of service platforms. What is your take, and when do you think the switch should happen?
Let me take that since you are building a cloud platform. I love open platforms. In fact, specifically, let's say we talk about Amazon. I love S3, because my reply is that build your, try and choose systems that don't import data and lock it into some vault, right, from where you can never get out the data. Another very interesting thing is all these classes of systems that we're talking about, specifically when we talk about Hadoop or MapReduce, they're excellent at pulling and exporting, importing and exporting large amounts of data. So if you really want to switch, your data set from, let's say you had a ton of data in SimpleDB and now you wanted to move it into Redshift or DynamoDB, right? You put up this Mongo, MapReduce cluster in the middle, you suck from one side and you dump into the other side. So, yeah, I mean, unless you go with a proprietary vendor who doesn't allow you those kind of full scan capabilities, I think you are in pretty good shape.
Now, from my perspective, I think it's, when you start off, you always start off very quickly, and that's because speed of business. I mean, you need to get there. And also, at some point in time, you see the large companies moving from public clouds to a hybrid maybe. So there's a lot of data you can actually take S3 or other advantage because just commodity, I don't care what data I'm putting in. There's nothing proprietary. They're not locking me in, as you said. It's fine. But if you have specific, highly tuned strategic advantage into that some system you're building, you will end up building a hybrid, your own data center where you have pieces of the puzzle where it's getting solved and a lot of data going into extending or, the elasticity part of it going into the cloud. So it doesn't have to be one way or other. I think it's, again, come down to, it's always a business. That's something which there's nothing you can do about it, I think. There's a lot of dollars going down the drain. So business guys will have a lot of say in it, and you'll have to work within those constraints, I think.
So we have time for two last questions.
I'm sorry, he had a...
Utkarsh was...
Oh, sorry.
When you are putting up the entire architectural piece, you are blending it together. You are being a good architect and trying to see whether it's a plug-and-play system. Everything should be redundant. You are just controlling the input and the output. Whether what is the choice of tool or technology, that should be redundant.
So my question is more on the machine learning side of it. So basically, for systems like Google, okay, and like search is one core component of Flipkart, okay, and of course it will not be at the level of let's say Google, okay, but if you want to mine patterns, if you want to mine let's say recommendations, okay, or even in terms of do some amount of NLP, okay, you need some very historic data which may be 10, 12 years, okay. So in that context, okay, how will you go about it? Okay, in terms of data storage from processing, storage to processing to getting that final actionable decisions.
So I think it goes back to his little bit of what Ashok was saying. You know, think of it like a tiered system, where historical data is going into very cheap, large-scale storage. You know, whether could be files in Hadoop or plain file system, it doesn't really matter where you're storing. Something cheap. Run a batch. So you're running learning from that historical using machine learning or any other techniques you may use to derive a pattern. But once you derive pattern, once you derive metrics and knowledge out of that, you have to push it back into the transaction system. So for example, in catalog, if you want to show a promotion, you have to push it all the way back. You can't try accessing real time into a machine learning kind of a system. You learn that, bring it back, and apply to the catalog system where the catalog has the intelligence, derived intelligence, coming back from large amount of data. Then that's what you're displaying. That's what you're using for transactionality. So that's where you close the cycle. It's the same thing. When you do he runs operations, right? You run the entire supply chain.
I was.
So you know the warehouse management system. You know, the most or the least interesting technical issues. You know, but you worry about your pick-pack cycle, and you worry about how many times this picker is walking between the aisles. Are you making him run around everywhere? Or are you picking him, proper order picking, item picking? So very different strategies applied, but these are all learned from historical data. You learn from it, apply it to transactional data. For that, it's too different. You don't try accessing while somebody is browsing. Somebody is not running a machine learning at the back. You know, it's two different systems.
Just like a little joke, like just imagining like Ashok going back talking to his wife and saying, "Man, the pickers are taking way too long between the aisles." Sorry.
We have a question here.
Is that Srikanth?
Yeah, that's
Hey.
Srikanth.
Hi, I have a question on, I think we're talking about DBMS and NoSQL type of databases in general, I guess. So my question is, what is the maturity level for managing these systems in production? Because I feel that most often, I think the guys who develop on these databases end up managing it. I don't know how it works out in Flipkart. You know, you say that you have so many distinct databases. So how do you actually make sure it's running? And you know, when you put a data in it, it's really there and it's not gone somewhere. Because most of the system can think for themselves, doing partitioning and all kind of crazy stuff.
Yeah,
Thanks.
here probably Utkarsh can answer this. He's been the longest on the panel.
It is tricky, it is tough. Data stores are still maturing. So it can't be purely operational tech ops activity. In the initial days, developers take much more owners, and then it becomes a partnership between tech ops and developers. And then as we learn and mature, we pass on the owners to the tech ops team. The key point to note is that one of the another important tenet to note while choosing a data store is, what kind of a control we have, what kind of a monitoring, metering kind of an ability we have on top of these data stores. If it is like a black box, even though it looks good on the face of it, I'll not go for it. I need deeper visibility, I need deeper pluggability. Can I plug in my metrics? Can I monitor whatever SLAs that I need to on top of that data store? If I can do that, I'll go for the data store, pass on the owners to developers and say, okay, plug in your tools, set up enough metering, alarming, monitoring on top of it. And once we have matured enough, then TechOps, the operations team will take over.
So one last question. Okay, so we have one last question here.
While making any data storage choices, for example, taking MySQL or Mongo or Hadoop or whatever data storage choices you are making, some of these data storage choices are based on that what is the number of hits that you will be getting. For example, MySQL or any of the relational DB is able to handle millions of hits over a few millions of record very well. But when somebody goes for building a system, for initial 3 to 4 years of its life cycle, do they really need Cassandra or do they really need MongoDB? So, I mean, how many companies do have in the ecosystem which actually require it? Because there are times when some tech guys just out of passion choose this DB because they have some obsession for learning. So, I mean, and maybe that is not required at that point of time. So, how as an architect, your panelists take the decision, no, we'll focus on MySQL. Or if you choose a Cassandra and have a dedicated guy and suppose tomorrow he leaves out of the organization, how will you build the substitute for him?
So I'm guessing he's an engineering manager. He's definitely not.
So if I may quickly answer, I totally understand where you're coming from. A lot of people tend to choose just for the sake of choosing. I think that it has to come from the maturity of the architect, I suppose. When your architect is sitting and thinking, it's driven by the business need. I mean, what are you trying to build? Do you really need? It's like using a complex tool to solve something simple, right? So it might be easier to walk across than to drive a Ferrari or something, So it's about that maturity level of the architect. I totally agree with you that you have to choose based on what you need. You can always move it onto a larger scale system. Sometimes simplicity is what works. Most of the time simplicity works. So
I'd like to add to that. I think the data, because the data is changing, just thinking about people wanting to choose MySQL because that's what's been traditionally used for data storage. Just because the data is changing, you might want to look at other options. Generally, I've seen a lot of cases where people would want to go try something out only because the engineers want to try something new. But I strongly believe that because the data is changing, the way we want to store data, the way we want to analyze data, we should be looking at other data store options as well, other than the traditional ones. Not really sticking around thinking that it's worked for us traditionally. Let's just go ahead and work with it rather than looking at newer options.
Yeah. Let me throw a couple of numbers. So if you have a traditional disk and it's spinning, it's probably about 10 to 12 milliseconds once rotation will complete. So you can probably get a chance to write a block. This is one piece of thought that goes through my head when I pick a store. If I need to write more than what the disk will give me, then possibly I'll want massive partitioning. Cassandra and some of these stores are built for partitioning, but not so well built for atomicity across multiple rows. So a lot of the choice depends on, actually the entire choice of the data store to me, depends on the access pattern. How many reads, updates, deletes, inserts, and what are you going to read by? If you're going to read by the same key, yes, a key value store might scream over MySQL. If you're going to need massive partitioning, but initially for many startups, given that the scale is small, it'll probably work out well. Actually, Lucene as a storage and quick lookup, if you're going to look up by many random attributes, that's a great storage. Elasticsearch, very low on ops. One piece to remember, MySQL at the low end of the curve, very easy to operate. Go a bit further, and a database is probably the single most difficult system you can write. From what I can tell, if I had to choose between writing an OS and a database, transactional database is the harder one. That's an analytical Hadoop Hive framework is easier. than a transactional database. So there are lots of other issues once you scale. It's non-trivial.
And most large systems, I'm pretty sure you can talk about it, and most large systems have a combination of it. So Facebook is also a very heavy user of MySQL and everything else. Yahoo is one, Twitter is one, so there we are.
I might little like spin on this, right? You just heard a gentleman talk about product experience, right? I would request everybody to add to that list of books, the book by Daniel Kahneman, Thinking Fast and Slow. Most of us are lazy. We turn off our brains. Even the super architects, like, okay, I have to solve this problem. You know, this thing is doing it for me. Why will I think for so long, right? I'll challenge anybody in this company to build me a 2-node MySQL cluster in which I can do a rolling upgrade. Right? Challenge. You cannot do it. Right? MongoDB might be a crappy platform. It might, lose data once in a while, and there might be 1,000 problems with it. But if that is the thing that you're trying to do, that I just need a 2-node damn thing which doesn't go down, it'll just do it for you. Right? So your people, these people are not foolish. They are following the thinking fast and slow paradigm. They are looking at, look, I got to build an operationally efficient system, right? And I got like JSON data. Here's a JSON data store in which I can do a rolling upgrade, and I don't have to read a bloody Linux HA with DVRD manual to get that going, right? And actually, if you go to my Facebook, you have Harrison Fisk and Mark Callahan and Domus and the top MySQL guys sitting there. They can make anything work on MySQL, right? But that is not a correct analogy. The guy on the ground is thinking fast. He wants something that gets the job done without having Mark Callahan on the team.
Absolutely.
Okay. Thank you so much. That's all we have given the time today. And to me, every time I've spoken to these guys...
I might. You started saying jokes.
Okay.
Okay, so this owes to my, one of the VP engineering, I sit on the board for the company. He interviewed a person recently, and he said, do you work on NoSQL? He said, yeah, absolutely. I've worked on NoSQL. He said, what NoSQL system? He said, Oracle. He said, interviewer completely confused. He said, Oracle? He said, yeah. So he said, okay, how do you write? I said, I write everything Hibernate. So I never write SQL. He said, no SQL. Yeah. Wow, that's a new definition of NoSQL, So Oracle is a NoSQL platform, if you just want to be good at it.
I spent 2 years working with Pramod, but every time I've spoken to him or met Joydeep and others, it's always been an immense learning to me. And I'd like to thank all of them for coming here and sharing their thoughts, their experiences. Intentionally, the topic was very wide to actually extend this conversation into tea and probably around lunch as well. I'm hoping that most of you can be there with us for the rest of the day. Thank you so much, and now we'll break for tea.